And hey, it worked. We're live. What do you know? I think. Yes, it's still going. Okay, so here we go. Today's date, 4/13/21. Okay, objective, area of a triangle without the height. How do you find the area of a triangle without the height? Because we know the area of a triangle is normally, and you don't need to write this down. This you don't need to write down, but we know the area of any triangle is equal to 1/2 its base times its height, okay? Now the book, if you want to see the proof of why this works, what I'm going to show you, it's in the book, and what they do is they'll find the height using sine, and then they'll substitute it back in. So our area is going to be this. Now before we start, I want you to go ahead, and I do want you to draw a triangle. Draw any triangle, but don't draw it as a right triangle, okay? Draw any triangle, okay? Theta, okay? I'm just going to put theta there. Theta could be anywhere on this triangle, but I'm just going to put it there, okay? Actually, it's here on this example, right? The 40's over there. Now, here's what you need to know. There's no longer a hypotenuse. There is no hypotenuse. Everybody agree with that? It's not a right triangle. So we have an adjacent side, and we have another adjacent side. So we have like adjacent 1, adjacent 2. Does that make sense? And we have an opposite side, but there's no hypotenuse. So we have two adjacent sides because they're both next to the angle. Got it? Okay, we got two adjacent sides. So the formula is this, is equal to 1/2 my adjacent side times my other adjacent side times the sine of the angle. And that is the formula for the area. But you have to know, you must know, you have to know that, and that. So you must know, and in geometry, so you must know, and in geometry we talked about this side, angle, side. I don't know if you remember that or not, but you have to know side, angle, side. So you have to know that two sides and the inclusive angle. If you aren't given, so in trigonometry, look, trig means like 3, and in trigonometry, always need 3 things. If you don't have at least 3 things in trigonometry, you can't do the problem at all, okay? So let's take a look at example 1. We do have the 3 things, right? I've got the angle and I have the 2 adjacent sides. That's an adjacent because it's next to my angle. Here's my theta. Here's my adjacent and my adjacent, right? So we're just going to plug it into the formula. That's all we're going to do. So my area is going to be 1/2 10 times 9 times the sine of 40. Easy. You agree? That's it. That's the angle. That's the area. You don't need the height at all. It's already in there because this formula has the height in it if you were to take a look at 10 sine of 40. Okay, or I'm sorry, 9 sine of 40. 9 sine of 40 would already give you the height, and then times the base times 1/2. This would give you the height, okay? So I'm just going to use my calculator. I'm going to go 0.5 times 10 times 9, times 9 times the sine of 40. Here's my answer. That's the area of the triangle. About 28.9 centimeters squared. Thumbs up, pretty easy, right? Everybody agree with that? Super easy formula, okay? Okay, example 2. So now let's use a little bit of pre-calc and think. So the area of a triangle PQR is equal to 15. If P is 5 and Q is 10, find angle R. There are 2 possible answers. Oh, what does that mean? Well, let's see if I can draw it for you, okay? So I could draw PQR like this, okay? Okay, let me draw this triangle here first. Because this 2 triangles kind of confuses me, but 2 possible triangles, 2 possible answers, okay? Let's see if I can figure out why there's 2. And I could use a ruler, but I think this is probably good. So this is side P, right? which means this is angle P. This is side Q, right, which makes this angle Q, right? And I want to find the measure of angle R. So the first thing I did is I drew a triangle. So it says the area is 15 centimeters. P is 5. I drew it in 5. And Q is 10. I drew it in 10. And then I was able to label angle P and angle Q, right? I don't know angle R. That's what I'm finding. Now my formula is, for area, it's a 1/2 adjacent times adjacent times the sine of some angle. Okay, that's the formula I had yesterday. My adjacent sides, since I'm looking for R, 5 and 10, right? If I'm looking for R, my adjacent sides are 5 and 10. So I know the area. So I'm going to work this one backwards. So my area is 15, so I'm going to put 15 here. Okay? So, okay, 15 is equal to 1/2 times 5 times 10 times the sine of angle R, which I don't know, but I want to find R, okay? Okay, so I'm working this backwards. I knew I was looking at area. We talked about area of this triangle. So I did my area formula. I'm looking for angle R, so instead of theta, angle R, adjacent. Okay, so let's work it backwards. Okay, so let's solve for R. So I've got a 15 equals, let's see, 25. You get 25, 5 times 10 is 50. Half of that's 25. Sine of R, okay? Divide by 25. And so, hold on. I'm going to get 0.6, I think. Hold on. Don't have to do it in my head. I can just use the calculator. 15 divided by 25. Yeah, 0.6. I was right. So I've got 0.6 equals sine of R. Okay, now yesterday, what did we talk about? What button do you push when you want to find the angle? What button do you push when you need the angle? The inverse button, the blue button. Totally right. So I'm going to go sine inverse of 0.6, and I'm going to get my angle. Okay, so I'm going to go calculator. I'm going to go blue button, sine inverse. All right, 0.6, and I get an answer of about 36.9 degrees. Okay, there it is. Right? Cool. Now, it says there's two angles. It says there are two possible answers. So here's how the other one could have been drawn. I didn't draw it this way, but it could have been drawn like this. 10 and 5. Okay. And then angle R here, right? And here's my Q, and here's my P, right? So if that's all I know, then this triangle could have been drawn this way and have the exact same area. Isn't that weird? Just the way it's drawn, it could have the exact same area, couldn't it? I mean, it's just skinnier, but it could have the same area, right? So here's what happens. And we learned this in Algebra 2. It turns out in Algebra 2 that this 36.6 is also right here. Okay, that's the angle we found from 5 and 10. So this angle right here is a 36.9 degrees. That angle there. We learned that in Algebra 2. So then to find angle R in this triangle, we'll just subtract from 180. Because we get 180 degrees makes a straight line. So to find this angle R, it's just going to be my 180 minus my 36.9. Use my calculator. Minus 36.9, and I get an answer of about 143. So the other answer for angle R is about 143.1. Okay? How am I doing? I know. This is what I love about pre-calculus. It takes all the math you've learned in the past and puts it all together. Okay, example 3. Find the area of a regular pentagon inscribed in a circle with radius 6. Okay, well, shoot, better draw a picture, right? Actually, you guys, there are people that love to borrow my little things here. Let's see if I can do this. If I get a pentagon, this one's pretty beat up, but I think it'll work. If I can draw a picture. Here's my pentagon. I'll put a circle around it. Anybody want to borrow this? Yes, no? Any takers? Okay, good. I'll keep it then, okay? So I want to find the area of a regular pentagon inscribed in a circle with a radius of 6, okay? So the radius of 6. Hi, Faith.
Hello.
How are you? If you want to grab the notes here, I'll go for you. So you can just jump in with this, okay? Okay, so let's take a look. So we don't have a pentagon formula, but we have a triangle formula, right? So if it's 6 there, obviously it's 6 there, right? Capiche? Everybody agree with that? If I can find this angle, right? If I can find this angle, I got it made because I'd have side angle side. If I could find that angle, I'd have my side angle side. I can find the area of that triangle. We multiply it by 5 because I'll have 5 triangles. So there technically are 5 triangles, right?
If it makes a circle, can we just divide 360 by 5?
Smart girl. You could have taught this. That's what I was going to say next. There you go. So Dylan's totally right. So to find the angle, right, we're going to take 360 because of a circle, divided by 5, right? Nice job, Dylan. All right, so 360 divided by 5 is 72 degrees. So this angle is 72 degrees. So we have a formula, right? Our formula is 1/2 adjacent times adjacent times sine of theta, right? And that's what I have. So I'm going to find my area of my triangle is 1/2 adjacent times sine of theta, which is 72. We'll get that answer and we'll multiply by 5, right? Not super hard problem at all, okay? Okay, I'm going to go 0.5 times 6 times the sine is 72 degrees. I get an answer about a 17.1. And then multiply that times 5, right? So the pentagon with 17.1 times 5. And we get an answer about 85.6, okay? And it's area, so it's going to be centimeters squared. How am I doing? Okay? All right, not too bad. I like today, guys. If I can draw it, I like trig. If I can draw it, if I can see it, I can apply a formula, bam, I got her done, right? Okay, turn the page. All right, find the area of this quadrilateral. Well, I've got the same problem. I don't have a formula for a quadrilateral, but I've got a formula for a triangle, right? So I need a triangle. Well, the first thing I might do then is, I think I'll divide my triangle right here. Okay. So, triangle 1. And triangle 2, okay? This will be triangle 1 and triangle 2, okay? Now triangle 1 is pretty easy because it's a right triangle, right? Triangle 1 is not too bad. So if I want to find the area of triangle 1, oh, I might need some more information. Dang, where did I take this? Hold on, I might.
Wait, if you cut the triangle this way, then you have both the side lengths.
Yeah, and you can get that angle, but then you would be able enough to find it over here.
Oh.
Right?
Yeah.
I need to add something here to make this work. Let's put, I thought I had, this is supposed to be 10. That's supposed to be 10. Yep. Sorry about that. You need that. You need that. You always need 3 things, okay? So, my bad. Put a 10 there. I'll have to add that. Okay, so the area of triangle 1. That's a right triangle, right? Base times height divided by 2, right? Area is equal to 1/2 base times height, right? Everybody okay with that? That's just 35. And I'm going to circle that because I'm going to come back to that, right? Because if I need the full thing. Now triangle 2 is this one here. And I need more information. So for triangle 2, I need this angle, okay? And I need this side. So I've got a little bit of work to do, but I can do this. So let's go for the easy part first. Side C, it's a right triangle, Pythagoras theorem, right? You guys okay with that? So let's go for these. So first let's find side C. And I'm going to go 10 squared plus 7 squared equals C squared. Right? Clear. 10 squared plus 7 squared. And I'll square root that. Square root 149. And I get about 12.2, okay? Square root of 149 is about 12.2. Okay, so I'm going to put that in my picture. I need that 12.2. So that's 12.2. Now, I need theta. If I can find this angle here, I can subtract it from 115 and get that angle, right? If I can get this angle here, let's call that, that's theta. Let's call this alpha. You don't mind another Greek letter, alpha? Get used to it if you take a college math class, right? Get used to it. So, theta and alpha. So if I can find alpha, I can subtract from 115 to get theta. You okay with that? So I can just use regular right triangle trig. I've got opposite adjacent, right? To find alpha, I can set up tangent. So to find alpha, I'm going to go tangent of alpha is equal to 10 over 7, right? Opposite adjacent. And so we got to use the inverse button, right? So I'm going to go tangent inverse of 10 sevenths. Let's see here. Tan inverse of 10 divided by 7. I get an answer of 55 degrees. Okay, so if alpha is 55 degrees, then theta, we can get theta, right? So this is 55 degrees in here. So then to get theta, theta is just going to be 115 degrees minus 55 degrees. And I get 60 degrees. Okay, I'm getting close. So now I have my side angle side, right? Because that's how you find the area of my adjacent. I've got my two adjacents, find the area of a triangle. Look at my adjacent, my angle. So I'm going to go triangle 2 area. We're just going to go, all right, 1/2. Adjacent 1, 13. Adjacent 2, which is my 12.2, times the sine of 60. I'm going to use my calculator to do that. That's a really bad looking 60.5 times 13 times 12.2 times the sine of 60. And I answer about 68.7. We'll round it up. 68.7. So now I'll circle that because the total area, right, almost done. So my total is going to be my 35 from triangle 1 plus my 68.7 from triangle 2. Add those together. 35 plus 68.7. I get an answer of 103.7 centimeters squared. Okay. How's that? Okay, and there's our homework for today. if you haven't finished 9-1, please try and get that done by midnight tonight, okay? Come on, stop. 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 Stop.